So next point is difference equation. Now before this you have already studied about differential equation. So now let's have one recap about it. So if you are given a function y which is in the variable of x, then differential equation is nothing but a equation which involves a relation of y and its derivatives. For example, y dy by dx, d square y by dx square, d cube y upon dx cube. So these are the derivatives of y, and any relation between this all the terms is known as differential equation. So you can directly write it as y double dash plus y dash plus y plus x equals to something. So now this is differential equation. So you have already studied this. Now what is the difference equation? So for this we will have so now instead of variable x we will consider it as n. Okay, so now if y is a function, then for n equals to 0 we will have value of y. Suppose it is denoted as y0. For n equals to 1, value of y is y1. For 2 it is y2. For 3 it is y3, and so on. For nth term or nth value you will have yn. So like this. So now we have already defined this kind of data for a curve or a function. Now we are going to define it for a sequence. So now a equation in which y and its differences, so consecutive differences between the values of y, so we have to consider either y1 minus y0, y2 minus y1 or y3 minus y2 to take into consideration the differences between two consecutive values of y. Now a equation which involves y and its differences, that is delta y n, it is known as a difference equation. So for delta yn is nothing but a difference between yn plus 1 minus yn. So delta yn is the difference between the next term and the term itself. So this is what delta yn is. So now if you have this, another representation is delta y, delta square y, delta cube y. So we will see what are those. So now a definition can be stated as an equation which involves a dependent variable. Now which is the dependent variable? This yn is dependent variable, it depends on n. So this is dependent variable yn, and its differences is called as difference equation. Now when you see when you consider differential equation, this deals with any continuous function. Okay, you will be given continuous function, and then if you consider difference equation, then it deals with a discrete data, discrete points, and you have to consider there will be given discrete points. With respect to that discrete point, you will be given value of y, and you have to consider the difference between the consecutive values of y, and with the help of this you'll get one equation, and this is known as difference equation. Now, generally difference equation is obtained in an attempt to solve ODE. So if you are given any ordinary differential equation, you can make use of difference equation by finite difference method. That means you have to find difference of the finite terms, and the difference equation is in the relation between the differences of unknown function at one or more points. So now, while studying differential equation, you had come across one term, that is order of differential equation. It was nothing but the highest power of the derivative. That means suppose you had y double dash plus y dash plus x, then you could say that 2 is the power, therefore order of the differential equation was 2. Similarly, in case of difference equation, you have one concept, that is order of difference equation. So to find it, you have two methods. So first one is, if actually there are two ways of denoting a difference equation. First method is this one, another one is in the form of n plus 1 yn plus 2. So we'll see both the ways, but first we'll consider this one. So suppose we are given a differential equation delta q yn plus 3 delta square yn plus 2 delta yn minus 6yn equals to sin n. So suppose this is your given difference equation, then you can directly see the power, highest power of whatever the equation is. So highest power of delta is nothing but the order of the difference equation. Okay, so if suppose if you have delta square yn plus yn equals to 0, then you can say that 2 is the order of this difference equation. Now let us take the difference equation which we took previously, that is delta square yn plus yn equals to 0. Now if you consider this, then now let us consider this delta in terms of a shift operator. So if you consider delta, you have to convert it into a shift operator, that is denoted by E. Okay. Now the value of delta in terms of this shift variable is shift operator is nothing but E minus 1. So substituting delta as E minus 1 in the given difference equation, you will get E minus 1 whole square yn plus yn equals to 0. So expanding this E minus 1 whole square, so you'll get E square minus 2E plus 1 into yn plus yn equals to 0. Okay, so multiplying yn inside the term, inside the bracket, you'll get E square yn minus 2Eyn plus yn equals to 0. Okay, so now how this shift operator works. So if you are given E and the power of this shift operator is suppose n, and you are multiplying it with y of x, then what if the shift operator changes that y of x to y of x plus n. Okay, so the power is given to the value y term. So similarly you will get E square yn as yn plus 2 minus E power of A is 1, so minus 2 y of n plus 1 plus yn plus 1 is 2yn, which is equal to 0. So now this is the another form of denoting or writing a difference equation. You can either write it in the form of delta, or else you can write it in the form of yn plus 2, n plus 1 and so on. Again, you can have delta yn can be directly written as yn plus 1 minus yn, that is the difference between two consecutive terms, or the difference between yn and its next term. Okay, so now DE is mostly written in this form, and while solving the difference equation, we mostly make use of this kind of format. Now, general form of difference equation or linear difference equation is nothing but a naught y n plus x plus a1 y n plus x minus 1 plus up to so on a n y n, which is equal to f of n. So this kind of difference equation is known as linear difference equation, and it is over set of n values for n equals to 1 to up 0, 1 to up to so on, and a naught, a n minus 1 up to so on a naught are the functions of n. Okay, so now if you are given in this form, then you can directly say that highest power of delta is order. Okay, order of that difference equation. But if you are given difference equation in this form, then the order of difference equation is the difference between the largest and smallest suffix occurring in the difference equation, and you have to divide this. So divide this difference by unit of increment. So what does it mean? Let's see one example so that it's easy. So y n plus 2 minus 2y n plus 1 plus 2yn equals to 2 raised to n. Okay, so this is a given difference equation. Now to find the order, what you need to do is we have to subtract largest suffix or argument minus smallest argument upon unit of increment. So if you observe, then largest argument or largest suffix is nothing but n plus 2. So you have to take n plus 2, and smallest suffix is nothing but just n. So we have to subtract n upon unit of increment. Unit of increment is you have to see the increase in the value of n. So n, n plus 1, n plus 2. So each consecutive terms is increased by 1. So increment is just 1. So you'll get n minus n gets cancelled, so you get 2. So now the order of this difference equation is 2. So there are two ways to find order depending on the format of the difference equation. Now solution of a difference equation means expression of yn which satisfies the given difference equation. So suppose, let's take one example to find the solution. So now if you are given yn equals to 2 raised to n, so this is given, and for n equals to 0, 1, 2 up to so on. So we have to find one expression for which yn satisfies the given differential equation. So if you consider yn plus 1 minus 2yn, so now yn plus 1 is nothing but 2 raised to n plus 1 minus 2 into yn is nothing but 2 raised to n. So this will give you 2 raised to n plus 1 minus 2 raised to n plus 1, which is equal to 0. So this satisfies. So if you consider this difference equation, then it satisfies. Therefore yn equals to 2 raised to n is the solution of this differential equation yn plus 1 minus 2 yn equals to 0. Okay, so if you are given this kind of difference equation, you need to find value of yn such that if you substitute in this difference equation, you have to satisfy the given equation. Now as we have seen before, that if this is the format of linear difference equation. Now this, if fn is equal to 0, then this difference equation is known as homogeneous difference equation, and if this is not equal to 0, and it is known as non-homogeneous difference equation. We have seen this kind of concept earlier also. So now see an example. So it is given as yn equals to c1 3 raised to n plus c2 minus 1 raised to n. So what are the steps which we need to follow is, we have to first substitute n by n plus 1 and n plus 2. Okay, so you'll get yn plus 1 equals to c1 into 3 raised to n plus 1 plus c2 into minus 1 raised to n plus 1. So that's the first one. So you can again rearrange it to get yn plus 1 equals to c1 into 3 raised to n into 3 plus c2 into minus 1 raised to n into minus 1. So now what are the coefficients of 3 raised to n minus 1 raised to n? It is 3c1 3 raised to n minus 1, that is minus c2 into minus 1 raised to n. Again substituting n by n plus 2, you will get yn plus 2 equals to c1 into 3n plus 2 plus c2 into minus 1 raised to n plus 2. Okay, so now again similar way, 3 raised to n into 3 square plus c2 into minus 1 raised to n into minus 1 raised to 2. So this will get 9 c1 into 3 raised to n plus minus 1 square is 1, so c2 into minus 1 raised to n. Okay, now we need to consider one determinant. So for this, for the first row will be the first column will be yn, the given one, then yn plus 1, and the last one is yn plus 2. Okay, now the second column will be the coefficients of c1. So in this c1 is 3 raised to n. Okay, so what is the coefficient of this? It is 1. Then yn plus 1, it is 3, and for yn plus 2 it is 9. Similarly for third column will be coefficient of c2 into minus 1 raised to n. So here it is 1, then for yn plus 1 it is minus 1, and for yn plus 2 it is again 1. Okay, now we have to equate this determinant to 0. Now we need to solve this. So again yn into 3 minus of minus 9, so plus 9, so you can directly write it as 12, minus 1 into yn plus 1 minus plus minus minus plus, so plus yn plus 2 plus 1 into 9yn plus 1 minus 3yn plus 2 equals to 0. Okay, so solving this, 12yn, then minus 1 when it gets inside, it will become yn plus 1 minus yn plus 2 plus 9yn plus 1 minus 3yn plus 2, which is equal to 0. So now as there is only yn, 12yn, and now minus 9 minus yn plus 1 and plus 9yn plus 1, so this will get you plus 8yn plus 1, and minus yn plus 2 minus 3yn plus 2, it will give you minus 4yn plus 2, which is equal to 0. So now we can divide this with 4. So as to reduce this equation, you will get 3yn plus 2yn plus 1 minus yn plus 2, which is equal to 0. So in this way you can form a difference equation. Okay, so this is one way. Let's see another example.